Just to let everyone know, we have started recording. I think we'll kick off at 2 minutes past the hour, just to let anybody else just join. So we will kick off at 2 minutes past.
Yeah.
Super. People may still join, but I say let's get started. Brilliant. Over to Izas. Thank you.
Great. Thanks a lot, Victoria. Hello, everyone. Welcome to this session. We look forward to conducting this Assessing Data Landscape Maturity workshop with you. This session is brought to you by EASEST in partnership with Population Health Data and Analytics community, which is embedded within AnalystX. Pretty much a collaborative initiative between NHS England and industry expert strategic partners to share on past experiences, knowledge, best practices to build further on and improvise on the care and health section. I would like to introduce you to the team. Vinay, if we can go to the next slide. So the presenters today are going to be myself, Athang. I'm a data evangelist assisting organizations to realize the importance of data and establishing objectives for strategic data initiatives. My dear friend and colleague Vinay has been working extensively with data owners, SMEs, and data consumers to try and identify, establish business use cases, prioritize these business use cases, and for effective implementation, come up with strategic planning and change management to make most of this scenario. On the other hand, we also have Mandar. Mandar is a specialist in data when it comes all things data. Mandar is the man. He has been instrumental in creating and establishing data ecosystem architecture to literally going way beyond and creating roadmaps for continuous improvement and change management. So he would be covering most out of it. During this session, we also intend to touch upon EASES framework around data landscape assessment, which has evolved over a period while working collaboratively with large enterprises and international organizations. And yes, we will cover a bit of that as well. Mandar, Vinay, in the registration process, we've had a couple of questions and suggestions, pretty much covering 3 areas. So I would request you to take over and help us understand more around first how we decipher data ecosystems, the existing landscape, then implement or come up with a strategy for or a structure to execute a data landscape maturity assessment. And third one, bases the findings of the assessment, creating a roadmap for continuous improvement and enhancement. Over to you, Vinay.
Thanks, Athang. Hello, everyone. Good evening. Assuming all of you are in London and European area. So the starting point for this workshop is deciphering your data ecosystem. The reason we wanted to talk about this is because different organizations have different perception of what a data ecosystem means, right? And they are at a different level of data capabilities. So it's important to understand what a holistic data ecosystem looks like, and specifically in context of public health setup. So if we talk specifically of public health setup, you could expect receiving health related data from multiple sources. You can see all the sources on the left hand side: hospitals, pharmacies, medical devices, laboratories, and so on and so forth. These data could be structured data, as in well formatted, easily to parse data typically this would be like data coming in from other systems, health records, patients' data, physicians' data, right? Medical devices could actually be sending diagnostic streams, continuously sending diagnostics data for patients' health status, electronic prescriptions. So all these are structured data which come in public health setup, but there is a lot of unstructured data as well, which is typically images, right? Like laboratory reports, X-rays, handwritten prescriptions. In that's still fairly common in many parts of the world. ECG reports and those kind of stuff. Right. So when we look at a holistic public health data bank, it constitutes of all this information, is structured as well as unstructured data, and all of this can be put to good use in terms of deriving intelligence using artificial intelligence, machine learning, helping decision making process, automating it to a certain extent, predictive analysis, genetic mapping. These are all very advanced usage of health data. And at the same time, there are standard reports, dashboards, searching the publicly available data to kind of understand health related issues in specific regions. And of course, a lot of this data can be shared via APIs to any other healthcare systems using FHIR, HIPAA kind of compliant interfaces. All these outcomes do not directly come from structured or unstructured data. You really have to kind of transform your data into a usable form. It could be thematic data sets, which could be like a specific data which is very much related to a specific theme. So for example, data related to genetics or data related to vaccinations or a specific disease. Or it could be a data product created for a specific purpose. So for example, a report requires certain set of data and there is a data product which it uses. So it doesn't have to worry about where it is coming from. It's a curated data set already available. This whole process of transforming the structured and unstructured data into thematic data sets and data products, that's really what your data ecosystem should be capable of. Okay. Diving deep into what are typical components in a generic data architecture. Okay. So we'll focus the attention on the middle part of the slide where we see all the data which is coming in from the source system. There are a lot of data engineering components which help you ingest the data into the platform, uh, store the data, take it through various stages of cleansing, refinements, enrichment using data pipelines. This is typically what is called as the data engineering process. The data is actually taken through a well-defined set of uh, stages, right? And those each of those stages is basically going to yield a incrementally better quality of data, better usable data. That's what the data layers are, and it's a very important concept in the data ecosystem. If your layers are not created properly, you may not end up getting the best data which you want. A lot of data management tools are required to ensure that data is properly cataloged, the data is secure, you have all the right metadata which is required to support that data, ensure that the data is well governed, right people have right kind of access to each and every data set across different layers of data, right? And you also need to manage your data on an ongoing basis, which means changes into metadata, changes into the the pipelines as new data sets come in. So you have to also maintain multiple uh, environments for production, pre-production, development purposes, automation of deployment, CI/CD pipelines, monitoring metrics and reports. So all of this is basically part of the data landscape. Typically, the starting point for any organization is what you see as the data engineering bucket. So typical componentized way of creating your data landscape is that's where you start, because you can't really do anything without data engineering. And that's really the early stage, lowest level of maturity uh, to begin with. As you incrementally organize your data into layers, you put in place proper data management practices, you put in proper operational measures. That's how you kind of incrementally go from a lower maturity level to higher maturity level, which is what we will illustrate in rest of this presentation. One other point to be noted here is this is a very generic data architecture. Not each and everything is required for each and every case. So depending on whether you are handling confidentially data, what are your interoperability requirements, those kind of things really determine what you need, what you don't need. But this is like a more or less a representation of, if you want to have the best of every possible world, this is how your data ecosystem would look like. So I'll move ahead and hand it over to Mandar to help us understand how you grow from one level of maturity to another, and how do you really assess that, right, your maturity level. Over to you, Mandar.
Hey, thank you, Vinay. Good afternoon, all of you. So based on what Vinay just showed, we just had a look at the generic reference architecture that we all want to get to one day. Um, so if you just could go to the next slide, Vinay. Yeah. Now to reach this generic architecture, of course, what we have devised is this architecture keeps on updating as the industry upgrades, the tools upgrade, the methodologies, the way of constructing data landscapes become newer and newer. And our job is, as part of this methodology, is to continuously look at the changing industry best practices, enhancing best practices, and enhance that reference architecture, and enhance the maturity evaluation or maturity assessment model that we are going to talk about in the next few slides. But before we do that, uh, just in the context of this audience, right? So let's look at the key challenges that are faced today with the population health data, and challenges in order to make the integrated care systems, ICS, SSS, to be more effective, right? So if you look at the core tenets, right? So since it's public data, um, the core challenges are like creating shareable and accessible population health data trends and insights from data sets that are available with various trusts that are affiliated to NHS or Analytics, and even all those sources that have publicly available data about public health or population health, right? Then drawing insights from huge amount of unorganized population health data from numerous data sources, which could be medical health record systems, which could be publicly available data systems. The next challenge is, since this whole thing is a collaboration of looking at data from different organizations' efforts, and to derive or arrive at insights which help us determine the next steps to improve public health in general, and having a fair, homogeneous distribution, equal distribution of public health to all types of people in the society. Sharing these insights and data sets is also an important activity. Then collating data from um, from the historically available data sets, looking at health trends and inequality trends. That's the next challenge. And of course, then comes, once you have a massive data set, comes the activity of predicting future population health needs and trends and overall distributions. So the idea is to, if this ICSs have to become effective, they have to be equipped. The healthcare systems have to be equipped with good predictive analytics, good operational analytics about that indicate the best possible indicators of the public health in general, right? So Vinay, if you can go to the next slide. Right. So before I go to the challenges in terms of the technology landscape, uh, just think about that reference architecture that Vinay just talked about a while back. What we have done in this methodology or the assessment technique is we kind of have split um, that reference architecture final target landscape in various buckets or various areas, right? Which are fairly technical as well as techno business in nature, taking into consideration the business needs of different organizations. And I'll talk more about the detailing of that. But before we get to how to do that, the typically what happens in an organization is the organization start off with ad hoc reporting, wherein they buy tools like Tableau or Power BI or other tools and directly talk with the data sources. Maybe create one layer of transactional data in front of the data sources and start building analytics. Many people do that, and then they kind of generate fragmented and siloed analytics. Moreover, the typical nature is to extract data through requesting data sets from the owners of those medical systems. There's no real-time integration in many cases with the medical systems. So that puts it's always the historical data that you deal with, and you want to move to the real-time data assessment and analytics. That becomes a challenge. Uh, the nature of growth of your data ecosystem becomes very tactical. It is actually then treated as a cost center to begin with. Obviously, when multiple people are looking at multiple data sets, there's no consistent data privacy policies, no consistent security policies or access management policies. So this is an organically grown, your network or your data landscape becomes an organically grown landscape with a significant lack of governance and data management. Right. So if you could go to the next slide, Vinay. Right. So what the assessment methodology that we're going to talk about does this. So it basically splits the core areas that the analysis tackles for your data landscape into two main categories of buckets. One is the architectural and structural, and the second is more of data management and operational. So the architecture and structure are more systemic in nature. So they compose, they construct, and they design the flexibility, the scalability, the expandability of your data ecosystem. So there are five key areas, right? And this is what I was talking about when I said, in order to reach the reference architecture, you have to really, we have created these buckets or areas, and we have looked at the industry best practices, compiled a exhaustive list of criteria, and then bucketed them in these various categories or various areas to do the benchmarking of data ecosystems of organizations. So number one, data strategy. It is about how well aligned your data and analytics is with your business goals. Yeah, okay, your business could be doing anything, but how your analytics is actually, is it separating the transactional and business data from each other? Are your applications constructed that way? And is your data strategy aligned with that business goals? Okay. Then comes the data architecture and design, which is more of architectural and design of the whole platform, the data hub. Because today it is important to understand that the data hub is not a single data warehouse anymore. It's an ecosystem. It's a landscape. It could have multiple warehouses. It could have multiple data lakes. It could have lake houses. It could have multiple different technology-based, tool-based systems that compose your data ecosystem, and the governance and the security and the architecture and the landscaping has to actually look at all of those. Next is the data pipelining, which is your core data processing mechanism, data in flight as well as data at rest, when it flows from source to the highly transformed end of your data landscape, right? So there are so many different factors that you'll need to look at when you do your data pipelining, right? Then the data analytics. Once you have all your models built, are you creating the right models in order to serve the analytics? And the analytics could be in different forms. It could be highly enriching dashboards, or it could be at the other end of the spectrum, very raw data on top of which you want to build, machine learning models, predictive models. Okay. The next thing is the data quality or the metadata quality, which is about not only the quality of the core data itself, it is also about what metadata or what data you associate, non-core data you associate with your core transactional and business data. So these five things compose your structural and architectural type of characteristics. Uh, and the next one is data management and more of operational, where you look at factors like data operations, how you want to serve your data users, at what levels, at what layers, right? Your data security at all layers when the data flows into your data ecosystem and out. Um, um, what are the security measures that happen at different places, data governance, and then change management. And we'll talk a little bit of detail of each of these buckets by showing you some high level points of assessments. If you could go to the next slide. Okay, so now let's take a little deeper dive into the architectural and structural areas. One thing I want to just pause and highlight is this session is going to cover a little bit of technical stuff. The audience, assumed to be present in this, session is a mix of people who are analysts, who are influencers, who understand technology, who understand how data is to be deciphered in order to make sense out of it. So they are associated in technical and non-technical aspects. So, however, our focus is that unless you get the foundation of your data architecture and data strategy right, even serving the data to the non-technology data analysts or data scientists could be challenging. And we want to touch on those core issues through this methodology. Okay. So coming back to this architecture and structural areas. So data strategy, as I said, we looked at information architecture strategy. Is your population health data separated from transactional data? When you construct your applications itself, are you making sure that, okay, our population health data could be treated separately in those applications so that it could be pulled out into data systems, into different usable data sets, right? Um, um, is your data ecosystem created in a way that you could build applications on top of your core data platform, which could serve different purposes in the population health area? The next is data architecture and design, which means how scalable is your architecture, how expandable, how mutable. Is it only serving data, or is it also serving analytics? Is it data as a service, analytics as a service? What level of modeling maturity does it have? Does it model its core business entities and transactions at a very minimal level, or does it allow you or present to you advanced models on which you can really build even more advanced analytics? Then you come to data pipeline. So I'm just reading out the top 3 to 4 aspects in each of these areas. There's a whole bunch. So if you were to avail this methodology for any of your applications or data systems, it's a pretty exhaustive list in each of these categories. So talking about data pipelines, it is, how flexible are your data pipelines, how configurable they are, how reusable they are, how easily you can create or replicate those pipelines when you want to add new data sources and new transformations. Are the transformations reusable? How do they adhere to different principles of data quality, deduplication, sorry, error handling, alerting, caching, data loss strategies, data recovery strategies? All of those tenets are there being taken care of. Data lineage, it all happens in your core pipelines, right? The pipelines are the crux of your data ecosystem. Then comes the data quality and metadata, which is about how you classify your data. Number one is the quality of the data itself, its completeness, its uniqueness, its integrity, its trueness, its That's category one, and the second is the metadata about it. How you want to classify your data at each stage when the data flows to your ecosystem. Do you want to attach the right metadata so that it's classified, cataloged in the right way, so that it could be searched, it could be tagged, it could be discovered at any stage by any kind of user who needs it. That's what is included in the metadata or the quality of the metadata. The next thing is the data analytics, which is the ability to serve analytics. So the core data hub, the pipelines and all that, the core data hub or the data platform or the data warehouse is your modeling warehouse. How much analytics do you really build on top of it? How much actionable insights those analytics here? Are they really raw analytics or they advanced analytics? Okay, how do they serve your need to build predictive models and put those models back into your data platform as regular pipelines? That is what is composed in the tower of analytics, data analytics. Then the next four are the data management and operational bucket, right? Which means if we talk about data security first, it is identity first. Have you identified what is secure or sensitive information and what is not? For the sensitive information, what level of security are you implementing? Is it data level security? Is the infrastructure application level security? Is it masking, encryption? What have you done? And so best practices. So in industry, when we talk about the best practices, there are multiple levels of security aspects that apply to data, to the application that hosts the data, the infrastructure that hosts those applications of data, right? So there is a different level of application of security and in different ways. So the best practices talk about that. Then in the data governance, what are the data contracts between the different parties? Who owns what aspects of those data? What is the distribution between technical and business ownerships? Are the rules and responsibilities clearly defined? Then you have the next thing of data operations, where you more talk about the engineering operations. How many environments do you make available? Is it one environment for all users? Is it multiple environments for multiple types of users? How quickly you can create an environment for a data scientist having his own or her own workspace? What's the underlying build management? Is it automated? Is it DevOps based? Or is it manual in nature? And is it serving your consumers SLAs correctly? Are the SLAs well defined in order to change, serve those analytics? Then the change management is about establishing a standard set of standard operational model in order to basically make changes or make upgrades to this data ecosystem, and then reporting KRAs through various reports and so on. So those are the 9 buckets classified into structural, architectural, and data management, which actually apply to the reference architecture that we want to reach in various capacities. And we go to the deep level of criteria on each of these to look at what is the industry best practice for that criteria and evaluate how a particular ecosystem is doing on that criteria. Can you go to the next slide? Okay. Now, how do you actually identify the gaps? How do you start looking at what kind of analysis or what kind of deep dive should I sign up for? So let's look at this diagram. This is not to be confused with the reference architecture. What this shows you is no matter what your ecosystem looks like, especially in case of public health data, the data needs to be usable by different user groups right from the time it is ingested in your data ecosystem. So the data scientist will need raw data to create models out of it. A little more advanced, the core models would be needed by business analysts. So when you create the right references between your different entities and transactions, the business analyst would come and get those models and operate on them and create their own analytics, which they could show to different stakeholders. or get insights from that. Then you could have a little more analyzed models, semi-analyzed and highly analyzed data models, which give you direct actionable insights without having to really look into deeper and to search for the insights in the dashboards that you create, right? So which means the consumption is not only towards the end, it is along the way the data flows, right? And the conventional consumption that's on the right of this is about, established fixed kind of auto generating reports, auto generating or auto running ML well established predictive models. And the two last boxes are about downstream integration. So a smart ecosystem, if you have to really create an integrated care system, the data that is run through all these analytics should be able to, the platform should be able to feed those insights back into the applications, which could take certain decisions further to indicate something more. So this is completely becomes an automatic process. Plus, the other uses the pushing the enhanced analytics or the analytical findings onto an external repository, which could be then used by a larger spectrum of organizations and trusts that are part of NHS or this collaborative exercise. So if you go to the next one, yes, thank you. So the key challenges in all of these consumption areas is number one, data privacy. How sensitive is the data? Has it been identified, masked, encrypted? Is the data that needs to be hidden, not made available? Data security and accessibility, which is who has access to what data and at what stage, how secure your data is at each stage, how discoverable your data is, at each stage, whether I have defined the right metadata, have I tagged the data that I want to really catalog, have I cataloged the data, and is it been searchable, has it been made searchable and discoverable? Data integrity talks about the quality, correctness, completeness, uniqueness, and that is at all stages, right? While in flight and while at rest. The next one is whether data is your platform is built for data as a service, whether it is self-service servicing in nature, where I can discover the data sets I want and can get those data sets out of it through APIs or to write interfaces. And the last one is the actionable insights. At each stage, what level of insights are you building or making available to the users? If you could go to the next one. Okay, so let's go one more slide further. Yes, so when we talk about benchmarking, right? So we talked about 9 things, 9 categories, right? So let's for a moment leave aside the data strategy, which is an overarching capability, which is about looking at whether your data analytics system is aligned with your business goals. Let's keep that aside because it is an overarching thing. Let's look at those 8 things which are about architecture and design, pipelines, your data quality and metadata, data security, data operations, change management, and so on. Okay. What our methodology does is actually it actually compiles an exhaustive list of criteria looking at the industry standard, right? In each of those 8 buckets, which are listed here in this spider diagram, we analyze your data ecosystem or for that particular aspect which is covered by that area or bucket. Then we assign a maturity score. A maturity score is between 0 to 5, 0 being not mature at all, very ad hoc in nature, to 5 being highly mature, which meaning it is adhering to today's best practices. So one of the key things we ensure is the best practices always keep on enhancing as the industry standards enhance, right? So this green polygon that you see on the outside is always an adopting one. It always, so we have it's our moral responsibility as part of the owners of this methodology to ensure that the industry practices, the best industry practice, is immediately reflected in our methodology. So coming back to this methodology, we assign a maturity score in each of these areas and then finally create the maturity score of your data platform. And it's not a simple arithmetic. which is an average of all the individual maturity scores. It has different weighting mechanisms, weightages, and so on. Okay. So what the important aspect this diagram highlights is you don't want to be inside that immaturity trap, which is not even zero, which is maturity one for in each of this. So you don't want to be below maturity one. In fact, you want to be above maturity one, and you want to be as close as possible to the maturity 5. And so what that blue triangle, or sorry, the blue polygon indicates is like the that maturity diamond, if you want to call it. That's the kind of maturity you should at least have in your data ecosystem. And if you closely observe, it is not a 4 or 5 or for everything. It is 4 at least for some key parameters, and a 3 for the other ones, but not 2. So that's or in some cases it is touching 2 as well, but it has to be more than that. So what we are uh, suggesting and recommending, and these are all recommendations that are compiled from the industry, right? So which means that as per the industry recommendations, it is really important that your architecture and pipelines are well organized. But it's okay if you have sort of manual data operations for that matter. My purpose is getting served. I'm not covered with DevOps, highly automated setup in DevSecOps. That's fine. As long as I have processes in place that stick to my adherence to the data operations and SLAs, that's fine. So that's why a 2 in some of the areas is fine. Um, or 3 is something that we should achieve. 3 and 4 is what most of the areas or most of the buckets are distributed in, if you talk about scores. If you go to the next slide, Vinay. Okay, so what is this industry benchmark? Now we would be happy to get into details of this if you need further analysis of your data ecosystems from us. But in the gist and in the highlight, the industry best practice, the maturity assessment is made up of around 500 criteria points across 75 categories in these 9 core areas that we just talked about. Those 9 buckets. And this table tells you, uh, how those 75 different categories apply to these different core areas. And you see that data architecture and design, data pipelining has the most, right? Data quality and data analytics has the next highest. So these are the core aspects of your data platform. And it's a significant number, and this number can grow with time or even reduce with time as data landscapes become more and more mature, or the best practices become it's possible that some of the best practices can get consolidated, in which case our models would also consolidate. Okay, so we are continuously looking at the industry recommended best practices. We are continuously reflecting those in our criteria. We are continuously updating the number as well as the assessment level of each of those criteria when we do the assessments, right? Um, so one thing I want to talk about here is, let's say, um what does it really mean for a 5 in architecture, or a 1 or a 2 in architecture, design and architecture, right? What does maturity score of 5 really means? Okay, so as I said, 5 is, so let's for example take data architecture and design. Okay, um, in this category, we would, for example, go down as deep as looking at number one. Is your application or is your data ecosystem built into different layers? You have raw layer, landing layer, you have staging layer, and there's a purpose for each of those layers. Are you making sure that data lineage is taken care of at each level, each layer? Okay. Have you identified what are the key parameters from business perspective which need to be classified and discoverable? Have you identified the key parameters that need to be discoverable and classified at the technology level? And what measures have you taken for it? Right. The next would be something like, have you separated your business entity data from the transactional data? What kind of data model methodology have you implemented? Is it a data warehouse, a big warehouse, and let the consumers do their own analytics on top of that warehouse? Or is it as complex as a data mesh where every data, there's multiple data products on top of a core, and those data products are like products themselves, the users of which do not know that there's a data core supplying transformational models into that data product. So it's called a data mesh architecture. Is it as advanced as that? What data storage approach do you follow? Is your storage central? Is your compute centralized or decentralized? How well or automated is your integration with upstream and downstream systems? Have you built it for data as a service? Have you built it for analytics as a service? How reusable are your data models and data transformations and so on? Based on your technology. So we are technology agnostic. We, of course, in this category, we would look at, um, have you moved your data setup to a highly managed cloud-based infrastructure, or are you still sticking to old kind of on-premise methodologies? But in those buckets, we don't look at what technology stack you're really using, whether it's Snowflake or Redshift on the cloud areas. We won't look at that because that won't count in basically deciding your score. What would count is how optimized it is, how well designed it is. Is it making best use of the features that are available in that piece of software or application in the technology stack? So this, if all of this is highly adhering to the industry best practice, then we would say that um, your assessment score on data architecture and design is a 5. If it's as um, rudimentary as data being directly pulled from the sources and some analytics built in some BI tool, then it's 0 or 1. And then we sort of have a very methodical approach to look at how we arrive to 1, 2, 3, or 4 in that assessment. Same thing with data pipeline. So I just gave you an example of how deep we would go in when we decide a score of between 0 to 5. Vinay, can you go to the next? Okay. One more, please. Right. So I'll just, I think we need to have some time for question and answers. So one of the things that would come to your minds is, okay, how do I really decide what to go for in this assessment methodology, right? Do I go for every aspect, every tower, or do I go for some of it? So that really depends on what your purpose is, what the key focus area of your own data analytics platform is. If it's a highly self-serving data mesh kind of thing that you want to go for, and serve all types of users, your business users, your data analysts, your data scientists, then you go for an assessment that covers all areas. If you're more about collecting data from different data sources and making it available in different ways of analytical outputs, then data analytics, data quality, and metadata, because you need to classify your data, you need to categorize your data, and then the operations to make it available to the users in the way they want. That becomes important. If it's about acquiring data sets from large number of sources and composing ML models on top of it, which could be related to population health predictions, then you need to really look at architecture, data security, as well as data quality. So the list goes on. Then you could be an organization which is contributing your own data sets for integrated care systems to leverage. You could be an organization which is or your group within your organization uh, can be just the owners and creators and the managers of the different kinds of data sets for different users, right? It could be data science capabilities, or it could be real-time streaming based analytics. In which case, our recommendation is the minimalistic assessment of your assessment of the maturity of your landscape should cover the areas that we have shown here in each of these different types of focus areas of your analytical ecosystem. But a question would still remain that is there a standard generic prioritization or generic priority that we can go for? And the answer is yes. There are some recommendations that we have as to how you choose what areas to prioritize. Vinay, can you go to the next slide, please? Right. So of course, if you look at the ideal, you choose a deep dive for the entire ecosystem. It's a highly comprehensive one with 500 or even more evaluation criteria points. And this could be an exercise that would take around 3 to 4 weeks with a good amount of interaction with technology and business users and the technology creators or the uh, technology owners of this platform, data platform from your end. Um, the other option is you go for a generic core components, which is your data architecture, which is pretty comprehensive. As shown in the last slide, it covers around 100 points across 12, 15 different categories, just the architecture area, because it's pretty fairly comprehensive. So between architecture and design, data pipelines analysis, and data analytics, you cover half the number of assessment scope. Or you could be specific. It could a generic 250 or kind of 50% landscape, 50% analysis package would consume around 2 weeks of lot of meetings and discussions. And in each of those, there's no touching your data systems. There's no access that we need to your data systems. It is a list of criterion. We just need the person to have the right answers, whoever we talk to, right? And then you could be specific based on what you really want to do in your organization. You could be a group that is responsible for only machine learning or modeling, and then you could actually go for a customized package, which could be anywhere between 60 to 190 criteria points, and could take anywhere between starting with as low as 2 days to maybe 2 weeks. So a bunch of ways to look at how to really assess your data landscape uh, from a bunch of combinations that we can make available to you in this assessment methodology. That brings me to the end of what this assessment methodology is all about. It could have sounded technical, but it was the intent, because the understanding is the audience today is either a business user or a technology user, consumer, or owner of the data ecosystems in their own organizations. So with this, we can open the forum for questions.
Thanks, Mandar. Thanks, Mandar. Thanks, Vinay.
Yeah,
So yeah,
absolutely.
and any questions, please do let us know. But yeah, the premise of this is each organization is going to have its unique set of skills, setup, and goals. It is essential that such assessment exercises are driven internally, and we are more than happy to help around them to try and see how best we can achieve the maximum to the existing data ability within any organization.
Just to add to what Atang said, this is an overview of the methodology that we talked about. When people signed up for this session, we did see categories of questions, and there are some questions about having to know more about some specific technology stack implementations and the best practices around those. While it is not possible to cover them in this session, what our recommendation would be that if we go to deep dive in those individual buckets, no matter what technology stack you're using, the best practices do apply to any and every technology stack. So we could go down to that level of whether it's a Databricks, whether it's Spark-based ecosystem, whether it's Snowflake, whether it's a Oracle BI or Oracle Data Warehouse, doesn't matter. So I just wanted to address that point that we received as a embedded question during the registration.
Perfect. So I don't think we've got any questions. Victoria, do you have any questions at your end, or else we are good to conclude?
No more questions that have come through. I think that was really interesting. Thank you all. As they've all said, we've got all of our emails there. Please do reach out to us after the session if there's any more kind of questions, or if there's a deeper dive session that anybody requires, then I'm sure we could arrange that.
Yep.
I think if there's nothing more, we conclude slightly early. Thank you everyone for attending. Really great to see everyone today. We have recorded this and hopefully we'll make it available on the AnalystX YouTube channel. So please do watch out for that. And also go to the Centre of Excellence for more exciting events similar to this. But thank you very much, Izes. That was really interesting and helpful to many people, I'm sure.
Great. Thanks.
Thank
a
you,
lot,
Victoria, and
Thanks,
thank you all of
everyone.
you.
you.
Thank
Thank you.
Thank you.